Rec-
Ladies and gentlemen, please be ready as the event will kick off shortly. Before we begin, here are some reminders. Firstly, Please rename yourself according to the format that we have sent to you earlier. Kindly record your attendance by scanning the QR code presented on the screen or by clicking the link given in the chat box. Secondly, please keep yourself muted throughout the whole event to avoid interruption. Lastly, if you have any inquiry, please type it in the live chat box. On behalf of the organizing committee, we appreciate it if all of you can stay with us until the end of the event. Thank you. Ladies and gentlemen, please be ready as the event will kick off shortly. Before we begin, here are some reminders. Firstly, please rename yourself according to the format that we have sent to you earlier. Kindly record your attendance by scanning the QR code presented on the screen or by clicking the link given in the chat box. Secondly, please keep yourself muted throughout the whole event to avoid interruption. Lastly, if you have any inquiry, please type it in the live chat box. On behalf of the organizing committee, we appreciate it if all of you can stay with us until the end of the event. Thank you. A pleasant morning, ladies and gentlemen. Welcome to the second day of the National Chemical Engineering Exposure Camp, NSIC 2022. Thank you for coming. My name is Junjie and I'm honored to be your MC today. Today, we will be having a chemical engineering career sneak peek, a session where the current chemical engineers would share their working experiences in their respective fields after the opening ceremony. Then, we will move on to the introduction to palm oil processing by IChemE-POPSIG, followed by a short break. After a short break, the event will resume with a speed quiz session. Lastly, we will end our event with a closing ceremony. Before we enter our main event, I would like to thank our sponsors. Firstly, I would like to thank Milkadil Sendirian Berhad. Milkadil is an online cashback portal that rewards you for your online shopping. Secondly, I would like to appreciate Precious Gifts Malaysia Sendirian Berhad. Precious is an e-commerce website specializing in personalized gifts in which anybody can design for their loved ones with a personal and DIY touch to it. The next sponsor I would like to thank is Good Morning Global Sendirian Berhad, which promotes healthy and functional 18 greens beverages that are suitable for whole family members for better immunity, stronger stamina, for healthy skin and vision. Last but not least, I would like to extend my gratitude to Hermo. Hermo.my is the leading beauty e-commerce website in Malaysia that provides a window of promotions between 200 brands and consumers. Without their contribution, this event would not have been a success. Do accept our deepest gratitude. Now, let's begin our opening ceremony with a speech by the current president of Institution of Chemical Engineers, Universiti Malaya Student Chapter, Ms. Gan Ying. Ms. Ying, the floor is now yours.
Thank you, MC of today, Jie. So, allow me to start my speech. So, morning all. I hope you guys have a good rest as today. And I know it's kind of early right now, so I just make it short and casual. First of all, on behalf of IChemE-Universiti Malaysia Student Chapter, I would like to express my gratitude and warmest welcome to the honorable guests, representative of IChemE-POPSIG Malaysia, Mr. Vincent and Mr. Oscar, Madam Surabi from Shell, lecturers from matriculation colleges, as well as all the participants for being with us today. And I'm wondering, how are you guys doing after the first day of this camp? I hope yesterday was not a too much information day for you all and doesn't give you all fright to pursue chemical engineering in the future. As a current chemical engineering undergraduate, I couldn't agree with all the speakers more. And yes, that's the true world of chemical engineering. But bear in mind that nothing is ever easy. You guys are fortunate enough to be exposed to all this information before selecting your future pathway. We were in your position, but we were so confused and uncertain about what exactly chemical engineering is. And so this is how we came up with the idea to organize this National Chemical Engineering Exposure Camp, which aims to provide a general overview of a chemical engineering degree to the pre-university students and also the diverse career options with a chemical engineering degree. I believe you all now have a brief idea on what chemical engineering is and how versatile it could be after all the insightful sharing from our speaker yesterday. And stay tuned for more interesting information about chemical engineering in the upcoming sessions. And taking this opportunity, I would also like to compliment the organizing committees for all the hard work and effort. In light of COVID-19 pandemic, we have to carry out this event virtually, and it's not easy to organize an online event. Nevertheless, the organizing committee bent over backwards to ensure all the participants have a wonderful experience. And it's no doubt they have reaped what they saw. And IChemE 2022 is definitely a huge success. Congratulations and kudos to the organizing committees. You guys have done a good job. And to be long with it, lastly, I hope all the participants have fun and gain some useful information throughout the camp. All the best in your future endeavors, and hope to see you guys in UM and maybe in the Department of Chemical Engineering. Once again, on behalf of IChemE-Universiti Malaysia Student Chapter, I sincerely thank and acknowledge every one of you here and those who extended help to us to make this event a grand success. Thank you so much for having me here, and I'll pass the floor back to the MC. Thank you.
Thank you, Ms. Ying. Now, I would like to ask all the participants to turn on your cameras for the photography session.
Okay, page one ready. 1, 2, 3. Page two ready. 1, 2, 3. Page 3 ready. 1, 2. Thank you.
Thank you for your cooperation. Without further ado, let us move to the next session, which is the Chemical Engineering Career Sneak Peek Series, Oil and Gas Industry. Before we invite our speaker to have a talk, I would like to remind all the participants about a few house rules. Firstly, please make sure your microphone is muted throughout the whole session to avoid unnecessary interruption. Secondly, if you have any questions that you would like to ask the speaker, kindly proceed to www.menti.com and key in the code 2675-5238 to pose your questions, or you may click the link provided in the chat box. Lastly, we will have a photography session with our speaker at the end of this session, and all the participants are encouraged to switch on your camera for this memorable moment. Honorably, we are fortunate enough to invite Madam Surabi Nambia to host this session. For your information, Madam Surabi studied chemical engineering in the Imperial College London between the years of 2002 until 2006. Madam Surabi has been working for Shell both in Malaysia and in the UK for a total of 15 years, primarily as a process and senior process engineer in the liquefied natural gas as well as upstream oil and gas areas. Now, let us invite Madam Surabi to share with us her experience in the oil and gas industry. Madam Surabi, the floor is now yours.
Hi, good morning, Junji. You okay to hear me, right? Yep.
Yes, Madam Surabi, we can hear you.
All right. Thank you for the introduction. I will move on to, I'll just share my presentation now, and I'll start with that. So let's do this. Okay. Yes. 1 minute. Okay. Hi. So here we are. Thank you very much for the introduction, and good morning to everybody who made the time on a Sunday morning, quite early for a Sunday morning, I guess, to be here. So this is me. I will be presenting the, as part of the National Chemical Engineering Exposure Camp to 2022, I'll be doing the small section on the career sneak peek into the oil and gas industry. This has been my area of work for quite a few years now, hence why I'm going to be talking about this area. So let's go ahead with me giving you a quick overview of what my agenda is going to be today. I'll start with a brief introduction. Of course, that's already been done. Thank you. But yeah, I'll just go through a couple points. I'm going to touch on chemical engineering, what and why, the simple definition of what it is, although I'm sure you guys, all of you here have a pretty decent idea of what it is already, given that this is day 2 of the event. The why in question is my why as to why I did chemical engineering. I'll move on to oil and gas, explaining it a little bit, why we're, what it is as an industry, why I chose it. I'll give a brief overview of it, of the industry specifically. I'll share some photos of the industry, stuff that's more relevant to me because I've done work in these sorts of areas. And I'll end my talk today with some common misconceptions within the oil and gas industry that people seem to have, especially for those who are not in the industry directly, of course. So about myself. I joined it was covered earlier, of course, but I'll just reiterate it. I joined university about 20 years ago, which is pretty much half my lifetime ago. So it's just made me realize my age. And I graduated 4 years later in 2006. I got my master's degree in chemical engineering from Imperial College in London. And whilst in Imperial College, I interned twice. I interned a few times, twice of which was in the oil and gas industry, both with the Shell company. I was very lucky to get those internships, and I enjoyed both of them immensely. They were both in very different areas of work, which made me realize that it is a vast and very complex industry. It's not always the same sort of work, as I will be sharing later on. I started working with Shell, thanks to, during one of the internships, I managed to do work well enough that I managed to procure a job with them. So I started working with them full-time in October of 2006 as a process engineer. So process engineer is a term I will throw out quite often in my talk. The reason being, when you join an industry like oil and gas, after having done chemical engineering, your role, you could do one of many roles, but one of them would be the most relevant one, I would say, closest to chemical engineering would be what they term a process engineer, because you're taking care of processes. And I've, as was mentioned earlier, I have experiences both in Malaysia and the UK. UK specifically in a place called Aberdeen in Scotland. And just on a side note, I have been a chartered member. I'm a chartered engineer with the IChemE, and I've been chartered since 2016, so for the past 6 years now. So let's move on to the main part of my presentation today: chemical engineering, what and why. So to put it very simply, and again, you're probably very familiar with this, given that this is day 2 of the event. To define it, chemical engineering involves the creation and development of processes to produce, change, and or transport products and materials in a safe and cost-effective way. It also involves investigation of problems and designing solutions for a variety of industries in a safe, efficient, and sustainable manner. Now, this is, of course, a lot of words, but what it basically comes down to is when you've got a raw material of some sort, be it oil and gas or a chemical or some form of agricultural product, and it's great. It's great. The core product or the original raw material is very useful, but we can't, as human beings, use them in their original form. You need to transform it from one form to the other. That's where you need to apply chemical processing or many different forms of processing, really, in order to get it from being, raw material A to end product B. And that's where chemical engineer comes in, because as part of chemical engineering or process engineering, as I've done, you would be you would be trained to manage or design the processes that will transform these products from raw material to end product. So, and the areas and industries in which chemical engineering knowledge can be applied are extremely vast. So I mentioned them a short while ago, of course, oil and gas, which is what we're talking about today, pharmaceuticals, cosmetics, household products, agriculture, like the palm oil that comes off in an oil palm plantation is a fabulous product, but you can't use it as it is. You need to transform it into something that is actually useful. So anything basically that requires some form of chemical processing to achieve the end product, ask a chemical engineer. To put it very simply, this leads into my why as to why I did ChemEng. In high school, I was always had a higher affinity for science-based subject. That was just my personal preference. I liked chemistry and physics and maths and all of those things. So it came in useful to then consider that I might want to go into a more science-based or engineering-based degree when it finally came to a point where I needed to make that decision. Chemical engineering appealed to me specifically because it offers a variety of different career options, as I mentioned above, oil and gas, pharmaceuticals, household products. So there's a variety of different industries that require the skill sets of a chemical engineer. Whereas from my perception, there was, there may have not been as wide an option in some other areas of engineering. This is purely the reason why I decided to go for chemical engineering. Of course, everybody has their own why, but I'm choosing to share mine here today. I'll move on to why oil and gas for me. So oil and gas in today's day and age, whilst there is plenty of work going into development of renewable energies and other forms or sources of energy, oil and gas still remains today in industry, in home use, in transport, one of the most important sources of energy there is. Yeah. So, I mean, from a very simple perspective, almost everyone or you yourself probably drive either a petrol or diesel car. that's oil and gas. What the petrol and the diesel that you put in your car, that is one of the main end products of the oil and gas industry, and you wouldn't be able to get around without it. So, and yes, there is a huge amount of development in the electrical vehicle industry, of course, and and it's moving that way. But from a global perspective, not just in cars, obviously, but in industry and in terms of systems and industries in place to support economies of many, many countries, especially developing countries, oil and gas plays a very, very important role still. It is vast in terms of both source material and products. So there's still a huge amount of source material, natural oil and gas reserves available in the world today. Not as much as there was obviously a few decades ago, but but processes and systems are getting more and more complex and detailed in its way to extract all of these reserves little by little. I personally liked oil and gas. One of the things because of the interesting processes involved in transforming the raw materials into the final product. So there are a variety of different processes, obviously, depending on where in the industry you sit. I've always found them fascinating because there are a variety of, depending on where you are in the whole chain of production of oil and gas, you'll see a whole bunch of different processes that make that are used to transform the products. And as a science person who's always been interested in sciences and engineering, I always found these fascinating. Of course, it is also a global industry. Something else I found always very attractive about oil and gas. You're not limited in terms of location. You get oil and gas in Malaysia, in Asia, and Australasia, but you also have oil and gas in parts of Europe, in parts of the UK, in the US, in the States, in Canada, in South America. So there are a variety of different areas that have oil and gas reserves and production. So very much a global industry, not limited in any space as such. So I will move on now to giving you a brief overview of the industry itself, just so you have some clarity on this. Excuse me. So let's take a step back. Yeah, what is oil and gas? So it's also known. Oil and gas can also be known as hydrocarbons. So in the industry, when we are talking on a day-to-day basis, you might very well come across the term, oh, yes, so how are we going to get those hydrocarbons from point A to point B, for example? The reason for this, of course, oil and gas are made up of very, very complex molecules. Maybe not as complex as some, but complex enough. But they're primarily made up of carbon and hydrogen atoms, hence the name hydrocarbons. These are not the only atoms and elements that make up oil and gas. There are a variety of other elements that make them up. Other gases like carbon dioxide, oxygen, nitrogen, if you will, the sulfur, lots of other elements that come into play, but primarily carbon and hydrogen. For those of you who, just out of high school, pre-U students, this will look very familiar to you. I'm sure if you've done chemistry, your periodic table. So I've circled the hydrogen and the carbon atoms there on the table just to indicate to you which are the main elements that you get in a hydrocarbon molecule, a hydrocarbon chain molecule, which is what oil and gas is made up of. So hydrocarbons or oil and gas can be found in its natural form in what is termed what we call reservoirs, oil and gas reservoirs. These can occur either underground or underwater. When I say underwater, I mean in the ground underwater, of course, not in the water itself. And it's called, they're called crude oil. In its natural form, oil is called crude oil and gas is called natural gas. I move on to the industry overview. So you've learned about the actual product, what it's made up of, mainly carbon and hydrogen. Now we move on to oil and gas, the industry overview. So to put it quite simplistically, the industry is split into three main sections. Obviously, there are subsections, but for this talk, I think it'll make sense to sort of look at the main sections first. Upstream, midstream, and downstream. I'll start by explaining the upstream section. It is also known as the E&P sector, or the exploration and production sector, because this is the area of the industry that is involved in discovering the underground and underwater crude oil and natural gas reserves, and also involves the processes and the skill set to drill into the ground, be it in the sea or on land, what they call oil and gas wells, to extract these resources and to then pipe them or transport them further down the process to subsequently subsequent operations and processing of the raw material. So you will see here on the far left side of the diagram that I've shared, you will see an offshore, or the more popular of these drawings is the offshore oil and gas platform that you can see over there with the little helicopter. So this is what this would be a typical symbol for an oil and gas platform, right in the middle of the ocean, where the oil and gas is being drilled from the ground under the water and being extracted up onto that platform, where a simple bit of processing takes place. After which it is then transported further downstream into the rest of the process, where further refining will take place. I move on to explaining the midstream section. This one involves mainly transportation, so storage and marketing of the product. So once you get it out of the ground, or wherever it is from the source point, from the source material that comes out of the ground, you then ideally need to get it to a place. Most areas where you would extract oil and gas, by and large, don't tend to be located in the friendliest of locations. When I say friendly, I mean it's not particularly urban. You don't have a lot of amenities around the place, so it makes sense to then take it out of the ground, wherever that may be, and transport it and store it at a place where it's more easily managed. Yeah, so that's where midstream comes in. The oil and gas reserves are usually transported in what we call huge pipelines, from one point to the next, where they will be then stored and further processed. Finally, there's the downstream section, which is what we term the product preparation and usage section of the industry. This is where further refining and further processing and purifying of the oil and gas takes place to then turn them into usable and consumable products. For example, your fuels, your car fuels, kerosene, bitumen, so on and so forth. Your petrol stations fall under the downstream section, the downstream retail section. Yeah, and just remembering that the upstream bit does take it out of the ground, but it doesn't do enough processing to be able to get us to the endpoint product that we need, which is why you need to split it up as I've shown here. In my career thus far, I have been lucky enough to have experiences both in the upstream sector as well as in the downstream sector, more so in the upstream. But I actually started my career in downstream for a few years, and then I worked my way into the upstream sector. So I've been fortunate enough to have a range of experience from the beginning to the end, so to speak. Yeah. Okay, I thought I'd share some photos here of the industry, because nothing like a few photos to explain stuff rather than words. So here, I've shared here on the left, that's a typical oil and gas platform. In fact, that particular one is an oil platform, if I'm not very much mistaken. I've chosen to show one right in the middle of the ocean rather than one on land, just because it's a very interesting structure. Mainly because you'll see on the left, of course, that's what you can see above the water. But on the right, you can see there's quite a lot of stuff going on underwater. And so the section of the platform that you can actually see are the small sections that you can see peeking above that are existing above the water level. But if you notice, when you drill down and you look at the bottom of the ocean, there's a hell of a lot of stuff going on there, because there's a lot of equipment, there's a lot of piping, there's a lot of control systems in place that are involved that are set up in order to process and efficiently manage the extraction of the oil and gas from the ground onto the platform, which you can, the platform being the part on top, which you can see which is then further processed and sent to a different location altogether where it can be refined further. So I've shown these photos just to illustrate how complex it actually can be under the water compared to what you see on top. So for me, the most of my career has been spent working on things like this. So my average day would involve either designing the overall process and then the smaller components of what we call the top sides. When we say top sides, I mean the section above the water. So what is being shown in the diagram on the left. And that would be for a new platform. So if there were a new platform, me and a team of other engineers would be involved in designing the overall process. But for an existing platform, one that has already been designed and has been in operations, I also have the experience of troubleshooting and working on the day-to-day operations of that platform, for example. So there's the bit where it's designed and put into production and operation, and then there's the section of needing to continuously support it throughout its operations as well. Keep in mind, of course, designing a process like the one on that platform, it's not a solo effort. It's not just the chemical engineer who sits and does it. I am part of a team of many other engineers. You need support from electrical people, civil, mechanical, controls. So there's a lot of different disciplines that come together to design one of these and turn it into from a pipe dream on a piece of paper all the way into actually an actual functioning platform like you see here today, like you see in this photo here. So that's all I have to say about these two photos. Let me move on to my next page. So this is an example on the left of a typical refinery complex. Now, refineries or refining, the final refining of the oil and gas falls under the downstream part of our of the industry. Yeah, so that's where all of the stuff has been drilled and extracted out of the ground, transported down to somewhere, usually on land, because the downstream refining and processing of oil and gas usually takes place, or actually always takes place on land, because there's a lot more going on. There's a lot more complex work going on, a lot more complex processing going on. So you need the space. And for that, it's best to be on land, not in the middle of the ocean. So this is a typical picture. You'll see these the cylindrical items that you can see in the front of the diagram I've shown here are sort of storage tanks. And as in all refining complexes, there's many processes that go on. Some of them more complex than others, but for the sake of this presentation here today, I've decided to touch on the process of distillation, because distillation is a very important process, both in chemical engineering as well as oil and gas. The reason I've chosen distillation is because I find it very relevant in our day-to-day lives, even at home. And I'm pretty sure I can't remember, I was in school a very long time ago. I can't recall if it was touched upon in school, but I think it may have been. Definitely touched upon in university. So distillation, what is it? I'm just giving you an example of a process that a chemical engineer would have to take care of in a refining complex, for example. Yeah. So what is distillation? To put it very simply, it is a process that transforms a vapor of a particular liquid, transforms a liquid into vapor, sorry, and the subsequent condensation of that vapor back into liquid form. The easiest example I can think of is a boiling kettle. You know, you put water in a kettle to boil, steam comes off, which is basically the liquid that's turned into vapor. So steam comes off, and if that steam comes into contact with the cold surface, you will see water droplets, because basically what's happened is that vapor is condensed back into its liquid form. Yeah. Now, why is this so important in oil and gas? Well, oil and gas, as I mentioned earlier, is very complex molecules, and which basically means there are many components within the oil and gas itself. Now, each of these components individually have their benefits. Each of them can be used for different reasons, for different benefits in different industries. So it would be a pity if the oil and gas is extracted in bulk and then sold off to the end user because there's so much more you can extract from it. Why do it in bulk when you can actually split it up into its individual components, and each component can be used for a different reason, and a variety of different industries can benefit as opposed to just one or two industries. Yeah. So that's where distillation comes into play in oil and gas. So you will see here on the right, I've just copied out a typical diagram of the distillation column. You get heated crude oil, for example, coming in at the bottom, all in liquid form because it's really, really hot. This one shows 350 degrees C. You don't want to be anywhere close to that. At the bottom, the stuff that still remains in liquid form is taken off as residue and fuel oil, for example. It can be used for roads, fuel for ships. You need really heavy stuff for that. But because it's heated up with such a high temperature, most of it will then transform into vapor, and it'll start traveling up the column, the distillation column, in vapor form. But as it cools down to specific points, the component within the oil and gas that condenses at that particular temperature, at that particular boiling point, we would call it in ChemEng, or in general, gets extracted out at that point. So as it say, for example, diesel oil would get extracted out at a particular temperature. The rest of the bulk oil and gas continues to, sorry, the bulk oil in this case, forgive me for saying gas, continues traveling up the column in vapor form. When it hits another temperature, kerosene gets condensed off, for example, and then the rest of it keeps traveling up. At a cooler temperature, gasoline gets taken off, for example, and then at the highest point, the lightest components, the ones that are still in vapor form, even after having been cooled down so much, gets taken off right at the top of the column. So this is where the distillation process, something very simple, which we can observe in our day-to-day life, can make such a huge difference in terms of extraction and efficiently maximizing the benefits within the oil and gas industry downstream, and one that is very, very close to a chemical engineer's heart. I will go on to discussing a few common misconceptions in our oil and gas industry. This is my last slide for today. So after this, I'll be ending the talk. So let's end on some misconceptions. First of all, oil and gas personnel get free petrol. Absolutely untrue. I wish it were true. That would be wonderful, of course. And I've been asked many times in my time working, hey, do you get free petrol since you work for Shell? And I've always had to disappoint people by saying, no, I'm afraid not. Yeah. Some people are under the impression that all oil and gas work is located offshore on an oil rig. Again, not true. As you can see from my presentation, there are very different parts of the industry. There's the upstream, midstream, downstream, all of which requires people. So yes, there are people who are located offshore on an oil rig, but then there's a hell of a lot of people located in all other parts of the industry as well. And of course, the people like myself, the chemical engineer, we are considered the technical experts in the industry, but there's a lot more that makes an industry work. You need people in the legal department, you need people in finance, you need people in marketing, you need people in sales, you need people who project manage things, you need people who develop business, who continuously improve the business. So there's a whole different myriad of and variety of different skill sets, and different industry, backgrounds that come into play when one is in the oil and gas industry. So, and most of these personnel are not located offshore at all. They're located onshore, mostly in an office. Offshore workers, there are plenty of those, but their numbers tend to be a little bit lower because offshore work, it is not the easiest of work. You would work on a rotation basis. You would work offshore, say 2 or 3 weeks at a time, and then you'd come off for a few weeks. So, it's not everybody is drawn to that sort of lifestyle as well. So basically, in summary, oil and gas work is a mixture of people who are offshore, onshore, and everything in between. Another misconception, oil shoots out of the ground easily. We've probably all seen the odd cartoon where someone's dug a spade into the ground somewhere and oil starts shooting up and going all over the place. Not so easy. It may have been easy a few decades ago in some parts of the world, not everywhere, but it is not the case anymore. Oil and gas is generally drilled in not the friendliest of locations sometimes. And it does require a lot of complex engineering and work in order to get it out of the ground these days. The time of easy oil, as they called it, is not quite there anymore. It was over from in the 1980s and the 1990s. The last one I have on my list is oil is mostly made up of dinosaur bones. I've heard this a few times as well. Now, oil and gas is also commonly known as fossil fuels. Now, the reason it's called fossil fuels is because they are made up of it's made up of the fossilized remains of animals and vegetation that existed millions of years ago, hundreds of millions of years ago, more likely. And which is what explains its high carbon content as well. As to whether any of that comes from dinosaurs, I doubt it. I don't think the timelines add up at all, but it is true that it is made up of mainly vegetation and animals that survived all those hundreds of millions of years ago. Hence why it is called fossil fuels. And that, ladies and gentlemen, brings me to the end of my presentation today. Thank you so much for your time. I would be open to taking questions now if anybody has any. Yeah, well, have a great day for those who have had questions, basically. Thank you so much.
Thank you, Madam Surabi. Now we will have a short Q&A session. If you have any questions that you would like to ask the speaker, kindly proceed to www.menti.com and key in the code 26755238 to post your questions. Or you may click the link provided in the chat box. Participants, please be patient while our technician team is sharing their screen. So now let's have a look at the first question. So, Madam Surabi, do you think it is a must to have a master's degree before entering into the oil and gas industry, since I noticed you have one?
No, I don't think it's a must. It may help depending on the type of job you're looking at. Yeah, so in some jobs it may set you apart. Yeah, compared to other places. But I can safely say that when I joined work, a large number of my colleagues were not master's degrees holders. They came into the bachelor degree, and then a few years down the line, some of them chose to move on to getting an MBA, for example. So they did get a master's degree, but not in the engineering space, because that might be something people like. They like the engineering, but they may want a master's later on in a completely different area. So no, I don't think it's a must-have. But depending on the kind of work, if you're looking at very specific technical work, it may give you an edge, but I do not think it's necessary. No.
Okay, thank you, Madam Surabi. Now let's proceed to the next question. So, is it very risky working at the oil rig?
Depends on your definition of risky. Yeah, it does come with its risks, yes. But in industry, there have been in the past, there have been oil rig or gas related incidents that have resulted in loss of life, but it happens very, very rarely. So I guess it depends on what your appetite is for risk, because if you're talking statistics, I think it's probably riskier to drive a car on the road. You know what I mean? So it just depends on what your interest is. For me personally, I can only speak. I would consider working on an oil rig. What I would struggle with is the fact that you work non-stop for 2 or 3 weeks, and then you come away and you get a holiday. You do an on and off rotation schedule. So you would work 2 or 3 weeks over there, and then you'd come off and you'd get 2 or 3 weeks on land, and then you'd go back and forth. So for me, it would be more the lack of routine that would be a higher level concern for me than the actual risks of working offshore, if you know what I mean. So it's about understanding what your priorities are. Of course, it comes with its risks. It is riskier than sitting in an office, for sure. But also that because of the way the industry is built, and because it is recognized as a risky environment, there is a lot of standards, very, very high safety standards that need to be adhered to in oil and gas offshore, because if they did not adhere to them, they would not be in operation in the first place. They wouldn't be allowed to operate. So yes, but if you were ever interested, or if the person in question is ever interested, they would probably get a very good they would be able to gauge. They'll be given a very good update on, look, this is what's involved. If you're cool with it, you do it. Otherwise, so it's very much a personal preference. I would work offshore if it weren't for the fact that I'm not sure I'd be able to handle the fluctuation of being only at work for a few weeks and then only, so I think it just depends on your priority. So yes, it does have its risks, yes, but depends on your risk appetite.
That's a wonderful answer. Thank you, Madam Surabi. So let's proceed to the next question. So do I have a chance to be sent out working overseas for Shell if I am currently working for Shell? If yes, how can I apply for it?
Yes, you do have a chance of being sent out overseas for Shell and any other, a lot of, not just Shell, a lot of oil and gas companies do have operations all over the world. I'll be honest, the options of moving overseas, not just in Shell, but in a lot of oil and gas space industries, have reduced over the years. It has reduced because the push in the world today, especially in oil and gas, maybe not so much in other industries, is very much to try and encourage local content of people to come and so, sort of encourage more Malaysians in Malaysia rather than expatriates in Malaysia, for example, and same for other countries, because from a business and industry perspective, I guess they're looking to be as economical as possible, like any other business. Yeah. So because if you were a non-citizen in a different country, they would need to accommodate for you more, obviously, because you're not a citizen of that country. So in short, yes, there is a possibility of being sent overseas, but less so than before. And you don't generally apply as well. I can only speak for Shell. I don't know about other companies because I've not worked there. But for Shell, anyway, if you were a Malaysian, you would generally apply for a Malaysian job via the normal website. So Shell has its website, and on there there's careers, and you can go on there and you can see what's available. In fact, there is this is just for Shell, obviously. Again, there is a career open day that you can register for, that is on the 10th to the 12th of March. So you can register for that online on the website. It should be there on the website, on the Shell website. But when you get a job, if you're a Malaysian, you would apply for a role, and if you're successful in getting through all the, they would assess you. Obviously, you'd have to go for interviews, you'd have to go for a panel type activities and all this, and you pass all that and you get the job, the likelihood is you'll get placed in a Malaysian role. But then you can see within that role whether you have the option of applying for something overseas, and whether that is something that you can work in your favor depending on what it is you want to do. So possibility is there, likelihood lower than it was, say, 10, 15 years ago. Yeah.
Okay, thank you, Madam Surabi. Now let's proceed to the next question. So what is the biggest difference between Malaysia and UK in terms of working style or the atmosphere?
My experience, so for me, Malaysia, I was always KL based, and in the UK I was in Aberdeen in Scotland, which is a much smaller town. Aberdeen is not the capital of Scotland, for example. It is a smaller town, so there was definitely a slightly healthier work-life balance in the UK, because you would have a shorter working day. And also I was in the operations space in the UK, as in I was supporting operations of offshore platforms it was an office-based job supporting the offshore operations of an oil platform, oil and gas platform. So my job required that I could occasionally go to the platform and come back, but I didn't have to be based offshore. But because of that, the people who work in operations tend to start their day very early. So we start early, but by 3:34 you're done. So then you have the rest of the day to spend with your family, with your friends, with your hobbies. So and because it was a small town as well, you could get everywhere within 10 to 15 minutes. So there was a lot more. There was a bigger mixture, I would say, of personal life as well as work life. There was better work-life balance, in my opinion. Malaysia, I've been lucky enough also that Shell, in that sense, again, I can't speak for any other company, I'm afraid. Shell has a good, even in Malaysia tends to be a little bit more work-centric, like a lot of Asian countries. Yeah, it's not a judgment. It is just unfortunately the way it is in a lot of places. They tend to be a lot more work-centric, but because Shell is a global company and it's an Anglo-Dutch company at its core, it does support better work-life balance. So even though I was in KL and you still need to work with a much more urban kind of space and needing to deal with traffic and needing to deal with slightly longer work hours, there was still good support in terms of in terms of being able to leave at a certain time and get stuff in your personal life. And there was always a lot of support in terms of, oh, you've got to go with this and do this for your family, go ahead. Oh, you've got, so I would say the support function was also very much present in Malaysia, even though it definitely does promote longer working hours and working days. I tend to, again, this is your preference. A lot of people would like the higher paced city-based sort of job role, and others prefer the slightly more laid-back, more country-centric kind of job role. Very much a personal thing, really. And I tend to fall into the latter category. I like having a good balance of my personal life as well as my work life, and some prefer it slightly the other way around. So again, depends on what you're looking for. That my biggest takeaway was the UK was a lot more, at least where I was in the UK, was a lot more relaxed. I think if I was working in London, it would be very different. Yeah. So yeah.
Okay, thank you for the wonderful answer, Madam Surabi. So let's have a look at another question. So what is the ratio of males and females working in the oil and gas industry?
Okay, so I wouldn't be able to give you an actual number because frankly, I don't know. I think we could all Google it quite easily, but definitely more male dominated still, but with a significant number of females also coming up, especially, let me think. Yeah, no, wherever I was, I gotta say, I had the advantage of always having a pretty balanced team of males and females, maybe a few more males and females, but always very balanced. My experience in the UK, because I was in operations support, and operations have traditionally been, you tend to get more men working offshore than you do women. More women now. But especially back in the day, especially you're talking like these are men who've been on offshore and working in rigs like for the last 2 decades, maybe, or 1.5 decades or so. So you'd probably come across more men in that space compared to women. But so I would say definitely male dominated still, but with a significant enough number of women that you don't look around and not see a female face anymore. That would have been the case back in the 80s and 90s. You would not have seen more than 1 or 2 female faces. Now you see way more than that. But what I want to point out is, at least from my perspective, I can't speak for every woman in the oil and gas industry. I never found that I had any difficulty working as a woman in the oil and gas industry. I was always lucky enough to be in roles where I was very well supported, regardless of who my colleagues were, be it male or female. So, yeah.
Thank you, Madam Surabi. So due to time constraints, let's end it with a last question. So let's have a look at the last question. So do you need to stay focused and be prepared all the time, day and night, working in the oil and gas industry?
I would say I'm not entirely sure what the question means. When I'm at work, I'm always focused, yes. But I was always in work roles where I could switch off when I left the day. Yeah. So, and also you have to understand, being in a work, if you are required to do a job, not just in oil and gas, anywhere where you are required to be focused and prepared 24/7, it's probably not going to be the healthiest job for your mental health. That's something you need to be really, really aware of. Like, some people are willing to put up with it, and if you are, but it will take a toll on you. So even as an offshore worker, even if someone who works offshore, they work in shifts, they work in 12-hour shifts. So they start at, say, 6 in the morning, and by 6 at night, they've passed it over to somebody else, and they get a full rest, because these guys are, like someone mentioned above,
Dear participants, I think Madam Surabi is disconnected. Please be patient and wait for a moment for Madam Surabi to reconnect.
okay. Hello.
Hello, Madam
You-
Surabi. We are glad to connect
Ah.
with you again. Shall we continue?
Sorry.
It's
Yes,
okay.
yes. Sorry about that. It's my internet. Yeah. How much should I answer that question again, or did you get any of it?
I think Madam Surabi have answered the question, and I
Okay.
get the point Madam Surabi trying to tell us. So
Yeah.
thank you for the questions, and thank you, Madam Surabi, for your answer.
No problem.
So
No
before we
problem.
move on, do you have anything to add on, Madam Surabi?
No, just thank you very much for having me here today, and I hope it was of use to all the participants, or in whatever way possible. Yeah.
Yeah, so all right, once again, thank you, Madam Surabi. Now, I
Thank
would like
you.
to ask all the participants to switch on your cameras for the photography session.
Okay, which one ready? 1, 2, 3. Which 2? 1, 2, 3. Which 3? 1, 2, 3. Okay, thank you.
So thank you for your cooperation. Dear participants, please be reminded that we will enter our second highlight of the events day, which is the introduction to palm oil processing by IChemE-POPSIG at 10 a.m. Please be patient while we are waiting for our speaker's arrival. Thank you. Welcome back, participants. Without any delay, we shall proceed to the next session, which is the Introduction to Palm Oil Processing by IChemE-POPSIG. For your information, POPSIG stands for Palm Oil Processing Special Interest Group. Before we invite our speaker to have his talk, I would like to remind all the participants about a few house rules. Firstly, please make sure that your microphone is muted throughout the whole session to avoid unnecessary interruption. Secondly, if you have any questions that you would like to ask the speaker, kindly proceed to www.menti.com and key in the code 2606-6962 to post your questions, or you may click the link provided in the chat box. Lastly, we will have a photography session with our speaker at the end of this session, and all the participants are encouraged to switch on your cameras for this memorable moment. For this session, we are lucky enough to invite Mr. Vincent Tiang to give us a talk about palm oil. For your information, he is an expert in the palm oil industry, and he currently works as a chemical engineer in IOI Pen Century Oil Chemicals Sendirian Berhad, Johor, Malaysia. He joined the POPSIG committee in October 2020 and began his role as Roadshow Deputy Director. Since January 2021, he has been the Roadshow Director at POPSIG. Now, let us invite Mr. Vincent to share with us some of his working experience. Mr. Vincent, the floor is yours now.
All right, thank you very much, Liu, for your kind introduction. So I'm very delighted to be invited here to IChemE-UM to share a little bit of my experience, also to give an overview to the participants here about the palm oil processing industry. Okay, so now allow me to share my screen. Okay, so my name is Vincent. So I'm from IChemE Palm Oil Processing Special Interest Group, POPSIG. So in this event this morning, I'll be presenting about the introduction of palm oil processing. So in this presentation, I will touch on basically two items. First, as per the title, is the palm oil processing industry. Then I will be explaining a little bit also about the role of chemical engineer in this industry. Okay, so when we talk about palm oil processing industry, it's definitely we need to first know about the palm oil itself. So actually, throughout the globe, there is numerous vegetable oils that is being produced and consumed. So this includes first definitely palm oil. Then we also have soybean oil, rapeseed oil, sunflower oil, and etc. So as you can see from the chart at the right hand side here, palm oil is actually the most produced vegetable oil in the world today. Why is it so? Because palm oil is by far the most efficient oil crops in the world. So you can see from the chart at the left hand side, actually palm oil it outmatches all other oil crops when it comes to efficiency per land use. Sorry, I just want to get my laser pointer. So as you can see this one, so the figure here is actually metric ton of vegetable oil per hectare of land. So you can see the great margin compared palm oil to rapeseed oil, sunflower oil, and soybean oil. So this shows that actually this also showing why why palm oil is the most produced vegetable oil in the world. Right, and also palm oil, the oil palm tree itself is actually grows in the equator region, where which is our country located at. So just for this map here, just want to it shows the importers and exporters of palm oil. So for the green color region, these are all the producers of palm oil. So actually, Indonesia and Malaysia, we are the two largest producers of palm oil. So we actually account a total of 86% of the world vegetable oil production, palm oil production. As for the exporters, our major exporter includes India, China, and European Union. Okay, so from the worldwide view, we'll zoom in a little bit to Malaysia. So Malaysia is actually the second largest producer and exporters of palm oil worldwide. So we produce 10% of the world's oils and fats for worldwide consumption. And in Malaysia, we actually we have 5.8 million hectares of land, which is 17.5% of our land mass is being used for oil palm plantation. And we also and then palm oil industry is the top 10 largest export earner for Malaysia in the last decade. In this industry, we directly employed 600,000 people. And in 2017, we saw the centennial celebration of the commercial oil palm planting. So actually, this palm oil industry has been more than 100 years in Malaysia. Okay, now well, we have a little bit of overview about palm oil itself. So I will get to the highlight of this presentation, which is palm oil processing. So actually, how do we get this palm oil from the oil palm tree? So the entire palm oil processing value chain actually in some ways is not so different from oil and gas industry. So in the oil and gas industry, as we know, there's actually an upstream, midstream, and downstream. So actually the same goes for palm oil industry. So I will explain using this flow chart here. So at the leftmost here is the palm fruit. This is where the oil is from, right? So once we harvest the fruit, we will send it to a palm oil mill. This is what the palm oil mill, and then also kernel crushing plant and biogas plant. Actually, this three section here is what we call upstream. Okay, then from the mill, from upstream, we will produce this what we call crude palm oil. So this crude palm oil will go to palm oil refinery to be refined. So this is what we call midstream. Then once we from the refinery, we produce the refined palm oil, we will send to the downstream section, which includes specialty fats producer, biodiesel producer, and also oleochemical producers. Okay, so now I will go a little bit detailed into each stream of the value chain. So the starting point of the journey. So to have palm oil, we need to have plantations, right? So this picture here is a typical oil palm plantations. So these are all the oil palm trees, and the right hand side here is the what we call fresh fruit bunch, or FFB, and all these tiny little orange color is actually the palm fruit. And you can see here the cross sectional of the palm fruit here. This is where we can extract the oil, and the inner side is also we can also extract oil from the inside. This one is the kernel. It's a different type of oil, what we call palm kernel oil. The outer layer is what we call crude palm oil. Okay, so this picture here is an example of oil palm mill, right? So what happens here is that the harvested fresh fruit bunch, or FFB, will be sent to this mill, and then inside this mill there will be series of processes where we will separate the fruits from the bunch, and then we will extract the oil from the fruits. So what are the processes? Okay, so these are the processes that is happening in a typical palm oil mill, right? So first we have the fresh fruit bunch that I mentioned earlier. You will go through first a sterilization process. This one to help to break out. This is the functions to help to break down the cell wall of the palm fruit. So it will make the extraction easier. They will go to threshing. So what threshing do is to remove the fruit from the bunch. Then the fruits will go through digestion and pressing. So from here, this is the main process where the extraction of the palm oil is happening. So once the digestion and pressing, we will get all all the liquid, which is the oil, will be sent to a clarifier for clarification. So what clarification do is basically to separate the solids from the oil. So the solid eventually the solid will settle down in the clarifier. Then the upper will be the oil. And this oil will send to centrifugation system, which is also another separation system. This is like for another like final polishing for the oil. Then after hit this centrifugation, we will get our final product, which is our crude palm oil, or in short, we call it CPO. Right. Moving on. So from here, for the pressing here, you will see there's another process flow. This actually for us to, because once we remove, once extract the oil from the fruit, the nut of the fruit is still there. So we didn't waste this nut because the nut itself also has a value, right? So what we do is you send the nut to nut crackling, and then to winnowing. Winnowing essentially is we are blowing air into the vessel. Then we follow up by a wet separation. After here, we will then from here we will get another our final product, which is palm kernel. So actually, this palm kernel, it will send to the kernel crushing plant. In my previous slide, showed there. So from there, we will extract the kernel oil from this palm kernel. Okay, so now after the palm oil mill, the crude palm oil and also the palm kernel oil will be sent to palm oil refinery and fractionation plant. So first, let's talk more about the palm oil refinery. So the picture at the right hand side here is an example of a palm oil refinery. So what happens here is that the oil refinery will produce the refined oil from the crude palm oil and palm kernel oil. So basically, the oil that we produce in the previous step will go through this process. This step will go to the refinery. So how we refine the oil is through basically 3 steps: is neutralization or degumming, next bleaching, and then deodorizing. Okay, so let's look at the refining process here. So in general, refining can be done either physically or chemically. Okay, so physical refining is the steps at the top here, which is degumming, bleaching, and deodorizing. While the chemical refining is the process at the bottom, which includes alkaline neutralization, bleaching, and deodorization. So here we see there's 2 steps, two kinds of refining method, but essentially the function is the same. So degumming is basically to remove the phosphate or what we call the gums from the oil. Same goes to neutralization. And bleaching is essentially to remove the color from the oil. And deodorization is to remove the odor from the oil. And then after this process, we will get the final product as refined, bleach, and deodorized palm oil. Or in short form, we call it RBD palm oil or RBD PO. So this final product and the raw material, it will have significant difference, which I will show in the my later slide. Okay, so this to give the participants a clear, a better visualization. So this is a typical palm oil refinery. So I think the process flow might look complicated, but I'll explain it in a simple help you understand it easier, right? So just now I mentioned that the refining process, there's 3 steps, right? So first, the degumming and all neutralization is happening in this reactor. So we add the reagent. So for degumming will be phosphoric acid. Then and then for neutralization, we're adding our alkaline. So here you will react. This here will remove the gums through the centrifuge here. You can see from this line. So actually this is where the first step of refining is happening. Then for bleaching, it will occur in this vessel we call a bleacher. we'll add in our adsorbents to bleach out the color from the oil. Then the deodorization is actually at this session. So it involves a vessel. Here we will do the heating, and then we have a column for distillation. Then after here, we will get our product at the bottom here, which is RBD oil or RBD palm oil. Okay. Then after refinery, we'll go to the downstream session. So the first downstream session I mentioned earlier is actually this what we call specialty fats production. Okay, so specialty fat, what happens there is actually the RBD PO that we produce from refinery, you will sort of undergo a process generally known as fat modification. So essentially what we're doing is we are modifying the physical properties of the oil. So that once we modify it, that property, the product will be able to apply in numerous applications, especially in the food industry. Okay, so for this fat modification, we have three types. First is hydrogenation. Here we would either be partial or full hydrogenation. Then we also have this interesterification. This process can be chemical and enzymatic. Then next we have this fractionation. It can be dry fractionation, solvent fractionation, or detergent fractionation. Okay, so I'll show you the process flow of each process. So again, it involves a lot of vessels. So it's to help you understand easier. So basically for hydrogenation, what we are doing is we are adding hydrogen gas and catalyst into the reactor here with the oil. So for here, this is where the reaction is happening. So the oil will be hydrogenated, or in another word, we are removing the double bond in the oil in the oil by adding hydrogen. So it will form more single bonds, and eventually it will become more saturated fat. It becomes hard fat in simple terms. As for interesterification, we are also adding catalyst and adding the oil. So from here, we also have it react with the catalyst inside this reactor. So this is also will help to what happening is it will help to reorganize the structure of the oil. And it will also alter its physical properties. Next, for fractionation. So fractionation, what we're doing is we are actually cooling the oil inside the vessel here. This is what we call it as crystallizer. So what we're doing is that we're feeding the oil to the crystallizer, and then we will also feed in the chill water to cool down the oil. So the oil will crystallize. But not all the oil will crystallize, but they built inside this RBDPO. There's actually like two fractions of oil. One is having a lower melting point, so that one will sort of like crystallize, and we will feed this crystallized oil to our filter press, and then we will separate the solid phase of the oil and the liquid phase of the oil. So the solid phase of the oil is actually called we call it as stearin, and the liquid oil we call it as olein. So from here, this is a flow chart of the typical fractionation process that I mentioned earlier. So the palm oil, we will separate to solid oil, we call stearin, and the liquid phase is what we call olein. But in fact, from olein, we can still further fractionate. We can still further fractionate to crystallize it to different fraction. So each fraction has their own application in the food industry. So for example, for olein, we can split into soft PMF, palm meat fraction. This can be used as margarine. Then we have super olein, which can be used as salad oil. Then for the soft PMF, we can split again to hard PMF. This can be used as cocoa butter equivalent. This will be mostly, you can mostly see this in our chocolate-based product. Then we also have this meat olein. And for super olein, we can also crystallize, become meat olein, and we also have top olein. This can be used for very cold stable salad oil. Okay, so this photo here are the products that is being produced from palm oil refinery and the fractionation plant. So at the left hand side here is crude palm oil. So it's a very orange, like very like sort of like a viscous liquid, right? Here, this actually a crude palm oil. So for this, we will send it to refinery. So we'll go through the 3-step process I mentioned earlier: degumming, bleaching, and deodorizing. Then we will produce RBDPO. So you can see the color is totally different because of the bleaching. We remove the color, this orange color, the pigment, so it will become white color actually. And then from here, actually inside this RBDPO, there's like 2 types of oil having different physical properties. So we will separate these the 2 oils out by fractionation. So it will become the solid one is here, the palm oil, RBD palm stearin. Then the liquid is RBD palm olein. So you can see the olein is liquid, stearin is solid. These are all under room temperatures. So actually stearin has lower melting point under normal condition. Okay, so now I have covered the refinery and the specialty fat section. So I'll go to the next downstream process, which is oleochemical production or oleochemical plant. Okay, so palm-based oleochemicals actually includes fatty acids, fatty alcohols, fatty amines, and methyl ester using palm oil feedstock. So these products are actually widely used in cosmetic, personal care application like skincare, hair care, oral care, and it can be also used for detergent, soap, and cleaners. So for the specialty fats and the refinery, most applications are actually at the food industry. But for oil chemicals, they are on cosmetic and personal care and cleaning applications. So I will go through a bit about the process. So the pathway within oil chemical industry, in general, we can oil chemicals can be categorized into 2 types. First is basic oil chemicals, which include these 5 chemicals: fatty acid, glycerin, methyl ester, fatty amines, and fatty alcohol. So these are the basic oil chemicals. So so the definition of basic oil chemicals is that they are the base for the foundation for their derivatives. So for these basic oil chemicals, we can further process it into what we call specialty oil chemicals, which is shown in this diagram here. So you can see the orange color are essentially the basic oil chemicals. Then it will extend out to different types of specialty chemicals. Okay, so these are just examples of the typical processes that's happening in the oil chemical industry. So because I'm actually now working in the oil chemical industry, so this will be like very close to me lah. So first, for oil chemical industry, to produce the basic oil chemicals, so first we will need a splitting process. So what splitting does is we feed in the oil, we feed in the water, then we heat it under pressure, then the oil will hydrolyze. Then it will hydrolyze, and then we'll produce out fatty acid. So essentially, fatty acid is produced from this one column here lah. We will get fatty acid, and then we also produce crude glycerin from this process as well, because we are splitting oil, essentially meaning we are actually, because oil for oil or triglyceride, there's a fatty acid and glycerol, right? So the glycerol eventually will mix with water, becomes our crude glycerin. This one, the glycerin water, and then glycerin water we will further treat and evaporate, and then we will produce the crude glycerin. And the fatty acid will also go through further processes. So this is basically the first step of oleochemical process. Then the photo at the right hand side, this is a glycerin refining. So just now the crude glycerin that we produce, it will go through a distillation process where we remove the impurities, and then the final product will be glycerin, what we call pharma grade glycerin. Sorry, the pharma grade glycerin needs to go to bleaching before that, but essentially this is actually like pure, like 99.9% of glycerin. And in the top here, we actually have a technical grade glycerin. This will be used for different applications, or we can send it back for further treatment, further process. And then this slide here, we have two types of process, distillation and fractionation. But essentially, they are having the same principle, which is distillation. So these two processes, what they do is, from the splitting process, we get our crude fatty acids. We fill into distillation columns. Then we will, for distillation columns, we will have a light end and a heavy end. So basically, we are separating the carbon chain, the different fatty acids from the crude feed itself. And then for fractionation, it's the same function. We are feeding in the crude, then we separating out by distillation to get different blends of fatty acid. Just that fractionation is able to give us a pure, or we are able to produce pure blend of fatty acids by fractionation. It is not, it can't be done in distillation process. So these are the major difference of the two process, but essentially, in terms of working principle, is the same. Okay, so just now I already explained the whole value, the whole production process from CPO all the way to the downstream, like specialty fats and other chemicals. So actually, all the products, all the oil that we produce, all the oil we produce are used in various industry. What we can see here, we can use it as food, we can use it for cleaning agents, cosmetics, healthcare products. So with that, it is not unrealistic to claim that actually more than half of the products that is on sale on supermarket are made with palm oil. All right, sorry. Okay, so now that I have covered the palm oil processing industry, since this event is more about giving exposure to the pre-U students about chemical engineering, so I would also like to touch a little bit on actually what chemical engineer is doing in this palm oil industry. All right, so actually what does chemical engineers do? So as you can see, actually in IChemE, we define actually definition for chemical engineer is we have a very we functions to help improve the quality of life. How do we do so? We actually first, chemical engineer will get ideas and knowledge from people together in biology, chemistry, maths, and physics, and we put it together as chemical engineering science. So from here, we by having understanding about the chemical engineering science, we're able to collaborate and exchange ideas with teams from other kind of disciplinary like mechanical, civils, electricals, etc. And then we will collaborate with them in research and development. From here, we will throughout this R&D, we are able to train and be educated, and then we are able to make the processes more sustainable and safer. So this is the major role of chemical engineers, regardless in what kind of industry. It can be in oil and gas, it can be water, and in my particular presentation, we'll be more talking about palm oil industry. But our role as a chemical engineer is essentially the same. Okay, so now we go a little bit more specific. So in palm oil processing industry, chemical engineers can actually apply the technical knowledge in the following practices. So what can we do? We can actually involve in process technologies. So because we have understanding on different kinds of chemical process technologies like distillation, crystallization, filtration, and separation, which I mentioned earlier in the previous slide. That right? So I'm sure like there are a few technologies like which is very, very close to chemical engineering. So we have the foundation, we have the knowledge of it. And then chemical engineers also have strong knowledge on mathematical modeling, such as catalyzed reaction, because the fat modification stage, right, is is mostly about catalysis, catalyzed reaction, and then we can also apply this knowledge in spread crystallization process. And then processes aside, chemical engineers also have strong knowledge in safety and loss prevention. So we have understanding about this the safety, so we can apply this in management of change and also in this HAZOP study. We also have knowledge in thermodynamics. We can use in hydrolysis process. We also have we also being trained as a chemical engineer to have critical and systematic thinking. So we're able to do system analysis, which will really helps in troubleshooting and control all the chemical processes. And we also have knowledge on the underlying chemistry. So this will be applied in processes like hydrolysis, which is a splitting process, and esterification, and also triesterification. And then chemical engineer is not just about dealing with engineering stuff. We also have knowledge on economic evaluation because we are designing plants. So from here, this will help us in plant debottlenecking and also in cost optimization. So these are the advantages of a chemical engineer in palm oil industry. And last but not least, chemical engineer also highlights on sustainability and environmental. Right. So we also, apart from just running the process, we also know have this. We also know how to optimize the process so that we can optimize all the resources that is involved in the process, and we also can help to convert waste into wealth. Like from palm oil industry, actually one of the byproduct is biomass. So how are we going to convert this biomass into something instead of a waste? These are all being done, and designed by chemical engineers. Okay, so in the palm oil industry, like in the current environment, where you can see, where you can actually find chemical engineers, actually there's a lot. So it's all been listed down here. You can see chemical engineers from definitely from the operation side, meaning from the process plant itself. There will be process engineer, production engineers in the plant. These are all chemical engineers background. You can also see chemical engineers from the design companies. Those are the people that actually help to design the plant, right? You can also see chemical engineers in the legalization areas, from R&D areas, from project management areas. You can see chemical engineers for academia for sure. You can also find chemical engineers in the quality and assurance of the palm oil industry, and also in sustainability development, in R&D. You can also see in instrument and control, and also see in sales, marketing, health, safety, risk management, and even computer application. So for all these areas, you can definitely find chemical engineers. And these are all the areas that is very, very critical in the palm oil industry. Okay, so that being said, we wouldn't make a very successful engineer if we don't equip ourselves with transferable skills. So one thing about chemical engineering is that we are not just learning, we are not just like very strong in technical knowledge. Because as I mentioned earlier, right, in my previous slide, like the definition of role of chemical engineers defined by IChemE. So one major thing is that we are not working in silos, right? So we as a chemical engineers, we are always like collaborating, working with people from other disciplinaries. So to do that, we not only need technical skills, but we also need transferable skills. So these transferable skills include managing relationships, leadership in professional roles, and also communicating ideas formally. So these are very important skills, actually not just for chemical engineers, for whatever professions that you're going to be in. These are all very important transferable soft skills. So what are the industry aspects from chemical engineers nowadays? So actually, they expect the industry expect us to be able to apply the knowledge and understanding in practical situations, because we are engineers. Eventually, we are being tasked to solve problems in the processes. So they expect us to have this kind of knowledge, and also they expect us to be not working in the silos. We are not supposed to work in silos. We should be able to plan, to manage interpersonal relationship and demonstrate leadership and communication skills. We should also commit to high standards of professional and ethical conduct as an engineer. And lastly, we are expected to commit continuing professional development related to our profession and knowledge and competence. So how are we going to develop and excel? So we must definitely have to know how to connect with people, and then we also have to go back with basics of all the fundamentals that we have learned, and then we uphold our professionalism. With that is how we can make a good chemical engineers, not just in palm oil industry, but in other industry as well. So I believe that's the end of my presentation. So I'm very sorry, I think I got a little bit off. So I'll pass it back to the MCs. So I hope my presentation can shed some light to the participants here today about the palm oil industry itself, also shed some light about chemical engineers itself also in the palm oil industry. Thank you.
Thank you, Mr. Vincent. It is the Q&A session now. If you have any questions that you would like to ask the speaker, kindly proceed to www.menti.com and key in the code 26066962 to post your questions, or you may click the link provided in the chat box. Participants, please be patient while our technician team is sharing their screen. Mr. Vincent, you may stop sharing your screen now. So let's have a look at the first question. So, Mr. Vincent, how do you see the palm oil industry in the next 10 years from now?
Oh, this is a very, very big question. So what do I see in the industry in the next 10 years? So definitely I can see the industry will be thriving, because palm oil is a very important commodity, vegetable oil, and not just in food industry, but also in the other applications like cosmetic and also for cleaning applications, etc. In fact, palm oil is also like now they are heavily used. They also have this being used in energy industry, like biodiesels. Also, we have this biomass that we can convert to waste. So there's a lot of potential in palm oil industry. So I definitely see the industry thriving. But I think there will be the challenges will be how to ensure this industry can be sustainable, because 10 years is a very long year. So even though we can see the demand increasing, but how are we going to ensure that if we are going to increase our production, how can we ensure that we are not producing more waste along the way? So this is why now, not just now, I mean for all this while, the industry has been focusing not only on production, but they're also putting sustainability of the industry in their priority, So now not only the companies themselves, the industry players themselves, also for example, even us like chemical engineers, they are engineers that now they're also doing R&Ds to design a more sustainable process for palm oil for example, biotechnology. Now biotechnology can be very, very sustainable. So now there are also people discussing and actually researching in this area. So I believe, and also we cannot forget about digitalization. Like this is a big thing, not just in palm oil industry, but in other industry as well. So all these things are actually like catching up, and I believe that the industry our industry is very vigilant. We are always like moving forward. So I think for me personally, definitely I will see the industry thriving for the coming years.
Okay, thank you, Mr. Vincent. Now let's move on to the second question.
All right, so yes, most of my colleagues are graduated from chemical engineering programs, because like myself, I'm working in other chemical plants. So my scope is actually to ensure my plant is running as per the is running efficiently and running safely. And we also need to and I'm also tasked to study, initiate this kind of improvement programs for my processes. So all these actually, to do this, you definitely need to have knowledge, foundation of chemical engineering. But it doesn't mean that you be a chemical engineer alone, you can like do everything, you know. You still need to, like I say, you need to collaborate with other disciplinaries like mechanicals and electricals, because in the end, if you when you go to work, it's not like everything is you're going to do everything. You have your own tasks, but to do a bigger projects, you need to work with others. So I mean, if you're talking about my department itself, yes, my colleagues are all graduated from chemical engineering programs, but as a whole industry itself, there's other disciplinary.
Such a wonderful answer. Thank you, Mr. Vincent. So let's proceed to the next question.
Oh,
so crude palm oil is today at about 8,000 per million ton. Does it make the industry to earn a lot?
I believe the crude palm oil price now is 8,000 ringgit per ton, not million ton. I think it should be metric ton. Right, the short form they use is MT lah. So yeah, basically now the crude palm oil price is at it's very high. In fact, it's all-time high. We have never seen this kind of price before. So if you are following closely with the news, the reason being this high is because first, definitely the conflict happens in Europe and within Ukraine and Russia, right? So that part causes a lot of things to price a lot of commodities to increase, which in the end affects the crude palm oil as well. Another thing is that now we are also facing the limitation of our supply. You know, like we have plantations, but now we are facing issues on harvesting all the fruits that we are producing. All these factor in cause this price causes crude palm oil to have 8,000 per ton. You know, but does it make the industry earn a lot? Yes, it will make the industry earn. You definitely have impact on the revenue. But another thing we also have to look into is that once your product has been this expensive, is the buyer willing to buy it continuously or not? Because now we are this kind of price increase, it will affect the whole value chain downward, you know. So to an extent, the market buyers, they will also have different kinds of reaction. So to answer this question properly, I would say yes, the industry will earn, but there is an extent to it, because if your raw mat price is too high, the whole market appetite will change as well. So this is another thing that we also have. The industry is also like carefully looking into it.
Okay, so due to time constraint, let's end it with the last question. So let's have a look at the last question. So to become an engineer in the palm oil processing industry, is there any more specific knowledge required apart from that knowledge that will be taught in chemical engineering program in university?
So specific knowledge required, I think maybe you need to know a little bit about palm oil industry itself. But for the processes, essentially, I would say that most of the things will be taught in your chemical engineering program. Just that it's just a matter of how deep will it be, you know, because chemical engineering, there's a lot to cover in chemical engineering program. So there are instances that you might just like touch some of the aspect of this program might be just like a little bit touch on the surface, you know. But but I think the important is if you have this basic knowledge, then you can there's no issue for you to become an engineer in palm oil processing industry. I mentioned earlier that the whole value chain is not much difference with oil and gas industry. So basically, whatever you learn, like in oil and gas industry, like more or less is similar like in palm oil industry, right? Because in chemical engineering program, you need to learn like reaction process, separation process, and I believe some or most programs are offering like bioprocessing courses as well, and also process control. All these things are actually not just applied in oil and gas industry, but also applied in palm oil processing industry. So I don't think if you want to have a specific knowledge required, I think maybe you can just go to the web and then have a look at the whole palm oil industry itself. But for the technical side, I believe mostly are covered in the program. It will be covered in the program, but some of it you will learn it when you start working in that industry. You will learn more along the way. This is what I feel like and what I experience in now. I hope I answered that question correctly.
Yes. So thank you for the questions and thank you, Mr. Vincent, for your answer. Before we proceed to the next session, do you have anything to add on, Mr. Vincent?
For me, again, I would like to thank this IChemE-UM for inviting me to this event. I'm very happy to join this event. And I know that actually the most participants are pre-U students, so I'm also very happy to like share my kind of perspective on palm oil industry and also in chemical engineering, just to give them a rough idea, to do some sharing to them. So hopefully my presentations, my sharing will like give some interest to the participants here about chemical engineering. So and also in the palm oil industry. So I hope everyone will do well in your upcoming your upcoming studies in the universities. So I wish you all the best. So thank you very much.
All right, once again, thank you, Mr. Vincent. Now, I would like to ask all the participants to switch on your cameras for the photography session.
Okay, for page 1, in 3, 2, 1. Smile, please. For page 2, in 3, 2, 1. Smile, please. And for page 3, in 3, 2, 1. Smile, please. Okay, thank you.
So thank you for your cooperation. This photography session marks an end for our today's talk sessions. And now we shall proceed to the exciting speed quiz session. But before that, let us take a short break to recharge our stamina as the speed quiz session will be a bit intensive. Participants, please take a good rest and get yourself prepared for the speed quiz session. We shall see each other again at 10:55 a.m. Thank you. Welcome back, participants. Glad to see you again, and we shall start our speed quiz session in no time. For your information, this speed quiz session will be carried out in 3 breakout rooms. Dear participants, please be patient while our facilitators are assigning you accordingly. Good luck and thank you.
Ladies and gentlemen, please be ready as our closing ceremony will start shortly. Thank you.
Ladies and gentlemen, welcome back, and we are now in the last phase of our event, which is the closing ceremony of NSIC 2022. My name is Heng Ching.
My name is Devin. We are honored to be your MCs for this closing ceremony. First and foremost, we would like to express our sincere gratitude to the sponsors of NSIC 2022. Firstly, we would like to thank IChemE-UM SC, which is an online cashback portal that rewards you for your online shopping.
Next, we would like to thank Precious Gift Malaysia Sdn Bhd for supporting us. Precious is an e-commerce website specializing in personalized gifts in which anybody can design their own gift.
Thirdly, we would like to thank Good Morning Global Sdn Bhd, which is a company promoting healthy and functional 18 grains beverages that are suitable for whole family members.
And lastly, we would like to thank Hermo for their support in our event. Hermo Malaysia is the leading beauty e-commerce website in Malaysia that has partnered with more than 200 brands locally and internationally. You can check out their website by clicking on the link provided in the chat box.
Yes, Heng Jing. Now to our sponsors, once again, thank you very much for your kind and generous support. Next, on behalf of the organizing committee of NSIC 2022, we would like to express our sincere appreciation to all speakers and our VIPs for being part of NSIC 2022 and sharing a lot of useful information to each and every one of us. It is truly our honor to have you all with us throughout this event.
Yes, Devin. And most importantly, we would like to thank all the participants for your participation in NSIC 2022. Without you all, NSIC 2022 would not be a success. On behalf of the organizing committee of NSIC 2022, we would like to thank all the participants for sparing your time and staying with us until the end of the event.
And lastly, we would like to thank all committee members and volunteers of NSIC 2022 for your hard work and effort in order to make NSIC 2022 a successful event over the past few months. Thank you for your contribution.
After 2 days, I believe our participants have actually gained a lot, especially in the chemical engineering field, from the introduction to chemical engineering until the future path of being a chemical engineer.
That is right, Heng Jing. Now, as the saying goes, goodbye does not mean the end, and it does not say forever either. It just simply means we will soon meet again. Therefore, we sincerely hope and we do look forward to seeing our participants in University Malaya in the future, especially in the Department of Chemical Engineering.
Yes, David, we surely welcome you all to University Malaya. Before we leave, kindly be reminded to leave your feedback on our event for future improvement. You may scan the QR code on the screen or click the link provided in the chat box. Last but not least, to end our event officially, we would like to apologize on behalf of the organizing committee of NSIC 2022 for any of our shortcomings throughout the event.
We wish you all the best in your studies until we meet again. See you, stay safe, and have a nice day.